So basically, let's move to the 5. The 5 asks us to find the integral of 1 plus theta all square over square root of theta. So the same thing, apply your algebra skills here by simplifying it. So in this way, you are going to get simplify the top ones, which is the 1 plus theta all squared. When you simplify it, you are supposed to get 1 plus 2 theta plus theta squared, right? So you replace it over there, which is the integral of 1 plus 2 theta plus theta squared all over, and you know square root of theta is the same as theta 1 over 2. And then further simplify it. When you further simplify it, what we are going to get is 1 over theta 1 over 2 plus 2 theta 1 over 2 plus theta squared over theta 1 over 2. And then don't forget there's the integral of it. So all the theta. So here you can just simplify it this way. Theta, integral of theta, negative 1 on 2. I just brought this one up here. So negative 1 on 2 becomes negative, plus, you know your indices. To divide a base with the same base, we subtract the exponent. So we have your 2 theta, and I have 1 here, so it's 1 minus 1 over 2. Because when I bring this one up here, it becomes negative. Plus, we are trying to simplify everything before we do the integration to make things simple for us. So theta 2 minus 1 over 2. I send this one up as well. The theta, and then at the end I have theta negative 1 over 2 plus the 2, and then theta 1 minus 1 over 2 give us theta 1 over 2, and then plus theta, which is 1.5, right, plus theta 1, which is actually 3 over 2. Yeah, 3 over 2 the theta. So 3 over 2 the theta, and now I think you are set to integrate it. So if you get it in this way, you just go ahead by doing theta negative 1 over 2 plus 1 plus 2 theta 1 over 2 plus 1. Don't forget to bring your 1 over 2 plus 1 here to be 1 over 2 plus 1. Here is negative positive, plus theta 3 over 2 plus 1 over 3 over 2 plus 1. So when you get this way, the rest will be algebra, and then you will get your final answer to be 2 theta 1 over 2 plus 4 over 3 theta 3 over 2 plus 2 over 5 theta 5 over 2, and then plus c. You can also decide to simplify depending on which of them you are comfortable. You can decide to leave it here, and you can decide to also simplify it by using your algebra knowledge skill, which is 4 over 3 square root of theta cubed plus 2 over 5 square root of theta 5 plus c. This is a further simplification, but basically you don't need it. You can leave it here if the lecturer or the teacher requires you to. So that is the differential, the question 1 plus theta all squared over square root of theta. Yes. So let's move to the next question, and the next question we have 4 cos 3x dx, 4 cos 3x dx, and we have the other one 5 sine 2 theta d theta. So doing the integral of 4 cos 3x dx is mostly trigonometric functions, and then for trigonometric functions, when you are doing the integration, this is what we do: differentiate whatever is inside the bracket and you divide, because the integration, you divide and then you integrate the cos function, the trig function as well. So this one we are going to get 4 and then multiply by 1 over, when I differentiate 3s, I'm going to get 3, and then when I integrate cos, I'm going to get sine. When I integrate cos, I'm going to get sine. Therefore, I'm going to get sine 3x. Don't forget plus, you are c, and therefore we are going to get 4 over 3 sine 3x plus c. So the next one is the II, which is 5 sine 2 theta. So as I said, differentiate whatever is in the brackets and then you divide. So now we are going to get 5 over 2, because when you differentiate 2 theta or 5 sine 2 theta with respect to theta, which is the theta here, we are going to get 2, and the 2 we divide. And then when you integrate sine, you're going to get negative cos. So multiply by negative cos 2 theta and then plus c. So therefore we are going to get negative 5 on 2 cos 2 theta plus c. So the last but one question, so before I leave the try questions for you to solve it yourself in your convenient time, let's look at the questions. 7 sec square 4t dt, 7 sec square 4t dt. So this question, when you get it this way, is the same thing, referring to the standard integrals that we discussed above. You can refer to those standard integrals. As I said, when you differentiate whatever is in the brackets, you divide, and then you refer to the standard integrals to integrate the sec square x. So when we do that, we are going to get 7, and when I differentiate 40, I'm going to get 4. So I'm going to divide it to be 1 over 4. And then when I look at the standard integral that we discussed above, the integration of sec square 4t will be tan 40, and therefore I'm going to get tan 40. So in combination, I'm going to get 7 over 4 tan 40 plus c. So let's look at our last but one question, our last question. The last question is the integral of, or 3 times the integral of cosec square 2 theta d theta. Cosec square 2 theta d theta. The same thing applies as we did to the 7. Refer to the standard integral, but as we are doing, differentiate whatever is in the bracket and divide instead of multiplying. So now we are going to get 3 times 1 over 2, because when I differentiate 2 theta, I get 2. And then referring to the standard integral, cosec square theta or 2 theta, it cots 2 theta, and therefore cot 2 theta. And then don't forget plus c, and therefore our final answer is 3 over 2, which is negative. Sorry, the integral of cosec square 2 theta is a negative of it, so don't forget to bring as well. So negative 3 over 2 cot 2 theta plus c. So this is the solution for this simple questions. And then I'll leave this trial questions for you to try. Try your hands on it. The first one is integral of 4 dx. The next one integral of 7x dx. Integral of 2 square root of x power 3 dx. The d is integral of 1 over 4 multiplied by the fourth root of x power 5 dx. And then the e is 5 integral of cot 2t cosec 2t dt. And then the f is 4 over 3 sec 4t tan 4t dt. And the last one, the g, it's 2 plus 3x all squared over square root of x dx. So please do well and get time to solve these questions. The more you practice, the more you become perfect. Thank you, and see you in my next video.